Good morning, everyone. My name is Alex Janicki. I'm Director of Marketing here for TriStar. I'm joined by Paul Dye. He is the Pre-Sales Technical Specialist for PTC's Virtual Center of Excellence. And today he's going to give you a presentation on Creo Simulation Live. It's a fully integrated real-time simulation solution for modeling inside your environment to kind of cut down on analysis and have instant feedback. If you notice, there is a handout that you can kind of browse through during the presentation. Any questions, just feel free to leave them in the chat and we will answer them at the end of the presentation. There also is going to be a recording given to everyone and a survey sent just about any feedback or future webinars that we want to do or that you would like to see. I encourage everyone to kind of take your time and submit that survey if you can. But with that, I'm going to pass it over to Paul.
Hey, thank you. So again, my name is Paul Dye. I'm with PTC in the Virtual Center of Excellence, and today I'm just going to be giving over a high-level overview of Creo Simulate Live. So with that, I'll just jump right in and get to talking about it. So before I really dive into everything, I just want to take a quick step back and look at some of the challenges that some of our other customers have voiced in the past, or maybe even some of the problems that you're seeing in your systems today. So speaking to analysis, most times it's just too time consuming in the early stages to really be viable because your models are always in a constant state of change, and most times your design engineers are really relying on experience and intuition whenever they're making all these critical design decisions. On top of that, there's really limited support for analysis-led design and optimization because analysis really is seen as something that only the experts can do, and that's mostly in the late stages of your design and development cycle process. That leads to reliance on late-stage physical prototyping and testing. Those prototypes are needed to validate the performance of designs, and that's basically due to a disconnect between the design world at the beginning and analysis, which tends to be later. With that, we're really trying to bridge that gap, and that's what we're doing with Creo Simulate Live. We're bringing real-time simulation capabilities into the CAD environment. With that, we're integrating ANSYS technology into Creo Parametric, and that allows our engineers to rapidly explore and start to instantly understand the impact of any of the design changes that we're making. So we're removing the barrier between our CAD systems and our computer-aided engineering systems, really creating a unified modeling and simulation environment. Again, we're integrating the simulation environment with the design environment. That's allowing engineers to see the changes and the analysis they're making as soon as they make any kind of modification to the model. It's really designed to be easy to use and works with the common data model. With that, we're really designing the extension with the designer in mind, not the analyst. We have a very consistent Creo user interface, and it's easy to set up whatever loads and constraints. It's actually very similar to what we use with our Creo Simulate model. So with that, ANSYS Discovery Live simulation is actually embedded natively within Creo Parametric. So we can still use all this parametric and direct modeling capabilities while also seeing the model simulation right on top of that. So with that, we have a lot of different capabilities. So we have many different types of analysis that's supported between linear, structural, thermal, and modal analysis. And the analysis changes based on whatever changes we make to the model, and that includes material changes. So that really starts to allow us to dive into a lot of different what-if scenarios that can start to be explored. And this Creo Simulate Live runs on a completely new technology, and that's powered by and developed by ANSYS. And that solver engine uses the GPU rather than the CPU. So with that, it actually requires the use of an NVIDIA graphics card, and we have an easy check that we're able to send out to whatever users that want to see if their hardware that's in their devices already can use that. And most times it's really uploaded on a lot of different hardware, and we shouldn't have any problem getting that checked out. So moving on with that, I just want to stop over into Creo so we can actually see what this looks like live. Okay, so today's focus in Creo is going to be on this Polaris snowmobile. So what I want to do is run this Creo Simulate Live and do some stress analysis on this iron chassis first on the part level, and we'll see how that looks, and then we'll move back to the whole assembly and see if it can really keep up with that increased complexity. So this again is the convergence of Creo Parametric and that ANSYS software. So this software is embedded natively into Creo Parametric, and our Creo users have direct access to 48 years of simulation expertise through the use of ANSYS. With that, we're going to start to set up our study. So get in, maybe start to define some materials for our part, and we can move into defining the structural parameters for our part. That first starts with defining constraints by fixing certain surfaces. I know maybe with this, I have a certain bar that I can't have this part move around. So lay that out. And then after that, we'll just go and select the areas where we want to apply our loads. And this is just normal, and that's how we'd go through in our normal traditional simulation process. But one thing, unlike the normal traditional simulation process, is we don't have to modify this part to conduct any analysis. All we have to do is simply apply the loads, apply our constraints, and run the simulation. No need to go through and take out any unnecessary rounds or holes, none of that. We just go through and define that. So running our simulation. In roughly 5 seconds, we have fast, instantaneous simulation results. So quickly analyzing what we're seeing here, we have some minimum and maximum that's actually appearing on the model itself. And we can see an animation of where we're having the most deformation. Maybe if we're interested in seeing a less exaggerated deformation animation, we can select true deformation. That gives us a better understanding of what this actually looks like with the model. This is really quick and easy, and for our designers, we're using these intuitive menus to start to see the effects of our loads and constraints. So now what I'm interested in is looking in a little bit closer into some of the stresses that we're seeing in the model. We see we have a high area of stress here. What I'm doing is I'm going to apply a simulation probe to get more information on whatever surface that I'm interested in. In that case, I'm more interested in seeing the resulting stresses that are going to be on this surface. We can see we have some stress values coming up, and we can refer back to that throughout our study. So let's make a design change to show off how powerful this engine is. So here I'm using flex modeling, which is just our tool for making instantaneous changes without causing any errors or mistakes. And as soon as I run that, look how quickly the simulation results are updated to show those displayed changes. So right there, we're seeing that drop off in any kind of stress values. And that's what we're worried about, is we're worried about the max stress in this area. So we want whatever design changes we make to alter that. Let's try out another change here. Let's maybe increase that round, and we'll see real time exactly how that stress value is going to be updated. And with that, we can start to refer to any changes we make throughout the design process and really see real time how that's having an effect on the model. Moving on, let's start to do a design exploration so we can start to study some of the effects of some of our design changes. So the design exploration extension is something that allows our users to explore alternative design changes without making any kind of risky or not editing any of the original design or overriding any files. What I want to do is start by applying another simulation probe to an area that we're interested in observing the maximum stress in. So I know that this is kind of an area that I know once I have this part into production, this is an important spot for me. I'm going to make some design changes to start to mess with that stress. So I'm going to go through and make a trajectory rib. And as we build this part out and secure that in, we're going to watch that value of our stress up in the top right, and we're going to see how that changes almost instantly as soon as we run the new part. And there we have it. And you can see that we're just simply working with Creo Parametric as we normally would, and CSL or Creo Simulate Live is integrated seamlessly and just works in, doesn't get in our way at all. So with the addition of these real-time simulation results, your design engineers can now focus more on their refinement and interactivity rather than having to iterate through all different kinds of designs and wait to get results back. So we've seen just how powerful this is in running that kind of structural analysis on just the part level. So I want to take a step back and see how powerful it is by running it on the entire chassis assembly. So this is going to start in the same way that we laid out some constraints earlier. So we have our fixed surfaces. We know that we don't want those to move around. And this is with, again, with this whole assembly. And I know maybe whenever I put in another part here, I'm gonna have some forces that are being applied. And maybe if it's shaking around, we're gonna have a downwards force on the right, and then it's gonna have a resulting upwards force on the left. So now that we have this laid out, let's go through and run our simulation. Okay, and just like that, we made it no time. We have instantaneous results. And normally designers would have to simplify the assembly, maybe just to get results back in hours or even days from an analyst. Now we're getting our results back in a matter of seconds. So just like in the part, we can identify any kind of max stress values, and we can start to animate that assembly to start to show our deformation results. Now I see that animation, I see there's a lot of deformation going up in the top right of our assembly. So again, let's apply a new simulation probe to an area that we're interested in, just like that. So we want to make sure this is within our certain area of range of values that we could see with deformation. We have about 1 millimeter of deformation here. Maybe that's within our bounds, maybe it's not. But now we know as soon as we make a design decision if it's going to be good for us or not. So let's exit out of insert mode here and just increase the complexity of our study even more and see how fast our deformation results are going to update for that. And there we have it. Just like that, a deformation result drops off and we're able to keep on moving with our design. So that's what we have for our structural analysis. What I want to stop into now is just to show off some of the other studies that we can go in and look at. So this is going to be more of a modal analysis. And to start that off, it's still the same process of setting up some loads and constraints, but it's going to be more for our vibrational analysis. Allow me to just quickly go through and start to define these loads and constraints, and then we'll jump right into another simulation again. First, I'll move back and look at this chassis because I'm not worried about the other parts right now. So define exactly what parts we want to study, and then we can jump in. So just as we did with the structural analysis, we're getting those fast, instantaneous results back with our vibrational studies. And again, we have a lot of different options when it comes to this. So we could run through different modes and see maybe, okay, if I'm running at a certain frequency, what's it going to be resulting on my model here? I see, okay, that's what's going to happen. That's how it's going to deform if I'm running at 60 hertz. Maybe I know it's going to be in another area as well, so I want to change that mode. I can go through and use our prescribed mode sets and see this is at 130 hertz about, and it's going to change what it's going to be updating on the model itself. So again, let's increase the values of our study and start to see how this modal analysis can keep up with that as well. And that's the whole thing here is we're making design changes as we're going through this process, and it's updating real time to keep up with these different modes. We can see that frequency value has changed as we've changed around the model a bit, and we can see with the new parts added and how it's going to be updated. And let's jump back and see that first analysis. Really a lot going on there, and that's helping us to start to drive our design intent. Okay, with that, I do also want to jump in and look at some thermal analysis, just so we can start to see how this process works the same for a thermal study. Okay, so here's another part I have up here. And again, we're working with the ANSYS simulation engine that's embedded right into Creo Parametric, and this is again working with something, and it's going to be kind of similar to how we did with the other previous examples with structural and modal. We're going through and defining our boundary conditions. So these are all things that we know that we want to insulate our model and study certain surfaces, or we don't want it to go outside of that. All right, so and then we can also decide maybe which surfaces are being heated due to convection, and we're also defining which ones might be receiving a load, and that's in the form of maybe a heat flow. Go through and we can quickly make changes, define any units for our study, and there's that heat flow value that we have being applied to one of the surfaces. So let's see what this looks like on the model. And there, right with that, we have this being updated on the model. We can see how that would translate to a different type of thermal study where we can even start to interrogate that model and look at where we have certain values appearing on this. We have a lot of different options. We can see maybe we like the view of this better. We can switch around, work with whatever we need to. And up here, we can see that's being updated in our graph as well. And again, we have this cross-reference with any points that we're looking at. You can see where we're having the lowest values, where we're starting to see some effects, where we might want to go in and change our design. So with that, that's all I really want to look at for in terms of a thermal study and just start to see some of the capabilities we have in this sense. Okay. So now we've really seen what this is capable of, and we can see how we can start to move forward with Creo Simulate Live. So this is really allowing engineers to perform any kind of analysis early and often. So we're bridging the gap between analysis and design. It's no longer these two separate worlds where our designer works on it and just sends it off to the analyst and just looks for a pass or fail. We can start to drive our designs based on the effects of our studies. We can get our products out faster and ultimately at a higher quality. So that's really the basis of Creo Simulate Live, and that's all I really wanted to go off and show on that. So if there's any questions, we'd love to talk about that or go over that now.
All right, looks like we do have one question. Will live simulation extension work with Creo 2 or 3 or 4, or is it just locked into Creo 5?
I believe that it is starting with Creo 4.0. I can check real quick on that to make sure that that is the case.
And then I'll just hold a few moments for any other questions. As mentioned earlier, everyone will receive a recording of this, and we do have a survey that's going to be sent out. It's just got some questions on what topics you might want to see in the future from us, some general things like that. And let's just give a moment for Paul.
Yep, just checking into that right now. I know it does run on 5 and 4, and let me just make sure about some of those earlier ones.
And if you do have any questions, you can always visit us online at tristar.com or just give us a call. We can kind of go into more detail, provide some more information, some more of the technical questions, things like that.
Yeah, and Alex, that is the earliest. It's working with Creo 4.0.
4.0 is the earliest. All right. We do have another question here. Are the failure modes handled differently for Simulate if features that drive conditions change?
Could you say that again?
Yeah. Are the failure modes handled differently for the simulation feature if features that drive the conditions change?
In terms
So,
of, yeah,
like, are the failure analysis modes handled differently for the simulation if the features that kind of affect it change?
will the failure modes change if the features that are affecting that change?
Yes, essentially. I
I
believe
would
that's the
believe so.
question.
And that's something that we could maybe make if something's changing or failing with the model, then you could go ahead and try out different maybe design changes, and this failure modes would update to show maybe, okay, what effect is that having? And if you go ahead and fix that maybe and change the model, it is being updated real time with that Creo Simulate Live as well.
Okay. Do you by any chance have any like examples of that, of just like making those changes?
We don't have any examples of that prepared for today, but if that's something that we wanted to take a deeper dive and look at something like that, we'd be perfectly fine to reach out to one of our field application engineers and set something up to maybe take a deeper dive into that.
Okay. Let's see if there's any more questions. All right. Paul, thank you so much. Again, everyone, thanks for attending. Feel free to visit us online at tristar.com and have a great rest of your morning.
Hey, thank you for having me on today. It's great talking to you guys, and have a good one.